Congratulations, you made it to the last example in this incredibly long section. Okay, hopefully you've been surviving through these examples. They aren't terribly difficult, but they do take a little bit of time. And because we're graphing, that takes up a lot of space. Okay, but we finally made it to example 6. And we've got the cheerleaders at Lake High School launch t-shirts into the crowd every time the Lakers score a touchdown. The height of the t-shirt can be modeled by our function h of x equals negative 16x squared plus 48x plus 6, where h of x represents the height in feet of the t-shirt after x seconds. So we want to graph this function. I'm going to replace this h of x with the y, and we know y equals negative 16x squared plus 48x plus 6. Now the good thing is they already gave us the function, so using this, it's just like the example we just did. We're going to plug in to find our axis of symmetry. We'd get negative 48 over positive 2 times a, which is negative 16. So we get negative 48 over negative 32. And when I do that, that would reduce down to 3 halves. So I know my axis of symmetry will go through 3 halves, which would be at 1 1/2 on the x-axis. Okay, now I'm going to plug in 3 halves into my equation to find out what my y value of my vertex is. So I get negative 16 times 3 halves squared plus 48 times 3 halves plus 6. Okay, when I do negative 16 times 3 halves squared, I get negative 36 plus 48 times 3 halves gives me 24. Sorry, not 24, 72 plus 6. Then when I just combine all these like terms, negative 36 plus 72 is 36, plus 6, I get 42. Now, I'm going to go up by 5s on my y-axis, and remember, whenever you change a scale, just draw in a couple numbers so you can tell how your scale is going to go. It's 5, 10, 15, 20. So I need to go over 3 halves, up 42, so here's 20, 25, 30, 35, 40. Right about there would be 42. Okay. And then I've got a negative 16x squared, but also so I know it's got to open down, but I can also find what my y-intercept is. My y-intercept, remember, is just your value of c. So I know my y-intercept is going to be down here at 0, 6. And because of that, I can just draw in my parabola that should look something like this. Again, not perfect, but I don't expect your graphs to ever look perfect in anything we do by hand. Okay, so we had our vertex, which was 3 halves, 42. Our y-intercept is 0, 6. So here's what our graph would look like. Then we just want to answer 2 quick questions. At what height was the t-shirt launched? Well, if you think about that, that's wherever the time would be 0. And time 0 is our y-intercept. And our y-intercept was 0, 6. So at what height was it launched? It was launched at 6 feet. And then the other question, what was the maximum height of the t-shirt? And when was the maximum height reached? Well, if you look at my graph, obviously right here is my maximum height. And I know what that maximum was because we know what the vertex is. The vertex is always going to be your maximum or your minimum. So I know what was the maximum height of the t-shirt. That was 42 feet. And when was the maximum time reached? That would just be my y value, or x value, which is 3 halves of a second.